Hello, space explorers. Caroline here. Today, we're about to take a trip to the moon. But you're not just going to watch. You're going to experience what it's like to land and walk on the moon's surface. You'll explore craters, visit future moon bases, and even imagine living on the moon. Are you up for it? In today's adventure, we'll explore the moon's surface features like craters and plains and discuss how they're formed. Relive historic moon missions from Apollo to Artemis. Imagine what it would be like to live on the moon and examine some of the challenges future astronauts might face. Ready to blast off? Mia looks like she's been ready. Let's put on our VR headsets and go! Look out the window of the lunar lander. The moon is coming into view. In just a few moments, we'll be landing on its surface. Prepare for landing in 3, 2, 1. We have touchdown. Let's choose what we should explore first. Let's start by exploring craters. Right now, you're coming up on one. Craters are one of the most common features of the moon's surface. A crater is a large bowl-shaped hole created when a space rock, like an asteroid or comet, crashes into the moon. Unlike Earth, the moon doesn't have an atmosphere to slow them down, so these space rocks hit at full speed, leaving behind huge craters. Let's take a closer look at this crater we're standing in front of. This is Tycho crater, one of the moon's largest and most famous craters. It was created by an asteroid impact millions of years ago. Let's keep going and take a closer look at the Maria, those large dark plains you see in front of you. Maria were formed by ancient lava flows. Long ago, when large asteroids hit the moon, they made huge basins, like giant bowls. Lava from deep inside the moon flowed up through cracks, filling these basins and hardened into smooth, dark plains. Today, these plains cover about 16% of the moon's surface, giving it the dark, blotchy appearance we see from Earth. See those tall, jagged mountains ahead of us? Those are the Terrae, or highlands, some of the oldest parts of the moon. Terrae are the lighter parts of the moon that we can see. When the moon was forming, parts of its surface rose up, creating these rugged, mountainous regions. Over time, they were further shaped by impacts from space rocks. But there's no atmosphere on the moon, which means there's no wind or rain eroding them. So how do you think this affects the way the moon's surface looks today? Pause the video and record your thoughts in your guided notes. Even though the lava stopped flowing long ago, the surface of the Maria has stayed smooth because there's no wind or rain on the moon to erode it. And without weather like we have on Earth, the Terrae and craters on the moon have mostly stayed the same too. So far, we've seen craters, Maria, and Terrae on the moon. These features tell the story of the moon's ancient past, shaped by impacts and volcanic activity. But humans have left their mark on the moon too. Let's step back in time and relive the first moments humans set foot here. Ready? Let's dive into history. Let's start by traveling back to 1969, when humans first landed on the moon during the Apollo 11 mission. The mission was led by astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins. Neil Armstrong became the first person to ever set foot on the moon. Imagine being Neil Armstrong, climbing down the ladder, about to step onto the moon for the very first time in human history. As Armstrong climbed down the ladder of the lunar lander, he said the famous words.
It's one small step for man, one giant leap for mankind.
Here we are, standing at the exact spot where the Apollo 11 lander touched down. Armstrong and Aldrin spent several hours walking on the moon's surface, conducting experiments and collecting rock samples, while Collins orbited the moon in the command module, waiting to bring them safely back to Earth. After Apollo 11, NASA sent more missions to the moon, with 6 total moon landings between 1969 and 1972. Astronauts collected more samples, performed experiments, and left scientific equipment on the moon to continue studying its surface. Why do you think scientists were so interested in studying the moon up close? What could we learn from moon rocks and other data collected from the surface? Pause the video and record your thoughts in your guided notes. Scientists studied the moon because its surface is like a time capsule of the solar system's history. Since the moon doesn't have an atmosphere, scientists think its surface has stayed unchanged since its formation, preserving evidence of impacts and volcanic activity. By studying moon rocks, we can learn about the early solar system and compare it with Earth's history. But since the Apollo 17 mission in 1972, humans haven't returned to the moon. Why? There are a few reasons. First, after the excitement of the Apollo missions, space exploration shifted focus. NASA and other space agencies turned their attention to building space stations, launching satellites, and sending robots and probes to explore other planets, like Mars. Another reason was cost. Landing on the moon was incredibly expensive, and many governments decided to invest in other projects. But the Apollo missions were just the beginning. Now NASA is planning to return to the moon with the Artemis missions. This time the goals are even bigger, exploring more of the moon than ever before, setting up a base where astronauts can live and work for longer periods, and using what we learn on the moon to prepare for future missions to Mars. We've walked with the astronauts of the past, but what about the future? Let's fast forward and imagine living on the moon. Imagine you're living on the moon in a home made from moon dust and rock using 3D printing technology. What do you think some of the challenges of living on the moon would be? Think about what we need here on Earth. Things like air, water, food, and warmth. How different would it be to live in a place with no atmosphere, extreme temperatures, and no fresh resources? Pause the video and record your thoughts in your guided notes. Living on the moon will be tough. One of the biggest challenges is the lack of an atmosphere. Here on Earth, we're surrounded by breathable air. But on the moon, there's no oxygen, so astronauts need special life support systems to keep air circulating inside their habitats. Another challenge is the moon's extreme temperatures. During the day, it can be as hot as 250 degrees Fahrenheit, while at night, it can drop to negative 208 degrees Fahrenheit. The moon has no atmosphere to regulate temperature, so astronauts will need habitats that can keep them warm at night and cool during the day. And of course, there's the problem of food and water. The moon has no fresh water, so astronauts will have to bring their own supply or recycle what they can. Growing food will be tricky too, because plants need sunlight, water, and nutrients. Scientists are working on ways to grow food in indoor gardens with artificial light and water recycling systems. These are just a few of the challenges of living on the moon, but with the right technology, astronauts will be able to create livable environments, places where they can breathe, stay warm, and even grow their own food. Imagine what it would be like to make the moon your home. Today, we've explored the moon's surface features and discussed how they're formed, relived historic moon missions from Apollo to Artemis, imagined what it would be like to live on the moon, and examined the challenges future astronauts might face. Phew, that was quite an adventure we took to the moon today through virtual reality. You can dive deeper into what we've covered today by exploring the additional activities for this lesson. In the next lesson, we'll explore solar and lunar eclipses. Until then, keep looking up at the stars and remember, you are out of this world. See you soon! Hey, hey.